In this video, we're going to be plugging the square root function into the definition of a derivative. Once we get the derivative, we're going to find the tangent line at x equals 2, as well as the normal line at x equals 2. Let's begin. Okay, so they gave us f of x is equal to the square root of 3 minus x. How do we find f of x plus h? So we can change the x's in this equation to x plus h. F of x plus h equals square root of 3 minus x plus h. Okay, so I'm going to change this to this real quick. Okay, what comes next? F of x, which is how much? Square root of 3 minus x. All over h. Okay, so we want to calculate this limit. Why can't we just plug in 0 for h? Well, let's go ahead and plug in 0 and see what happens. Okay, so if I plug in 0 for h, what does this part become? So this is going to turn into x plus 0, so this part just becomes x. And I'm going to copy this real quick. What goes on the bottom? 0. What does the top simplify as? Zero. Okay, so we ended up with 0 over 0. So what's the problem with this? If you plug into a limit and you get 0 over 0, it means that you have an indeterminate form. I'll write the word down, indeterminate form. So if you get 0 over 0, you're going to have to try something else to calculate the limit. And with the square roots, you can multiply by the conjugate, as I'll show in a second. So I'm going to multiply the top and bottom by the conjugate of this. What does conjugate mean? Conjugate means we copy this expression except the sign in the middle is reversed. So the opposite of subtraction is what? Addition. Everything else stays the same. So square root of 3 minus x plus h and square root of 3 minus x. So we have to multiply the top and bottom by the conjugate. Okay, so let's go ahead and do that. Why am I allowed to multiply the top and bottom by the conjugate? We're going to think of it as multiplying two fractions. So this is going to be the first fraction, and then this is going to be the second fraction. So basically I took this and multiplied it by how much? I multiplied it by 1. So this and this are the same value, just rewritten. So that's why this step works. The next step will involve simplifying the top. Okay, so how do we simplify the top? Well, we can use difference of squares. So difference of squares, as a quick recap, is a squared minus b squared is equal to a plus b times a minus b. Okay, so difference of squares. If you need a quick refresher on why this equation is true, you can FOIL the right-hand side. But how can we use this to simplify square root of 3 minus x plus h minus square root of 3 minus x times square root of 3 minus x plus h plus square root of 3 minus x? Well, this part looks very similar to this, and this part looks very similar to this. So this could be A, and this could be B. All right, A, B. So this expression looks like a plus b times a minus b. So that's why we use difference of squares here. That's what this is called, difference of squares. Okay, so a plus b times a minus b is equal to a squared minus b squared. If a is the square root of 3 minus x plus h, what would a squared be? Okay, so a is equal to the square root of 3 minus x plus h. What would a squared be equal to? What happens to the square root sign if I square both sides of this equation? It goes away. If b is equal to square root of 3 minus x, what would b squared be equal to? Well, it's the same idea. Square root sign goes away. All right. So a squared, let's go ahead and copy this. So 3 minus x plus h. So this whole thing, so I'm going to put brackets around it, minus this thing. So this whole thing, I need to put brackets around it. Okay, now I'm going to tell you the shortcut to get from here to here. But make sure that you understand why it works. Make sure you understand my explanation earlier before you start doing this. Okay, so basically, I'm going to just take this that's under this first square root. I'm just going to put it here. And take this under the second square root and put it here, and we're going to subtract them. Boom. Okay, so for the next step on our worksheet, the only thing that's going to change is this gets changed to this. And by the way, everything that I write in purple, you don't have to write when you show your work on the worksheet. Yeah, it's, I just do this to explain like why stuff works. All right, how do we simplify the top? This is gonna be 3 minus 3. All right, so let's cross that out. Wait, why are we allowed to cross the 3's out? Okay, so if I were to get rid of the brackets, what would this turn into? Minus 3, negative x. So double negatives is a positive. And, okay, so it's going to be 3 minus 3. So that's going to be 0. So this is going to be negative x plus h plus x. So this equals this, which is equal to this. The shortcut for getting from here to here is to just cross out the 3's, but make sure you understand why before you start doing this. This is going to be 3 minus 3. All right, so let's cross that out. And then, so we've got a minus x, and then minus x. Okay, so we crossed out the 3's. This is what we're left with. Why were we allowed to cross out the x's? Well, let's try to simplify this first. So it's going to be negative x plus h, and then we've got double negatives. So it's going to be plus x. All right, and when this simplifies, it's going to be negative x and negative h. Yeah, negative h. Okay, plus x. So I can cross this out and this out because they add up to 0. So basically, the reason why I was able to cross out the x's is because I saw that if we were to expand it out, we'd end up with a minus x, and would also end up with a plus x, which would cancel each other out. So that's why we're allowed to cross it out. And then we're just left with minus h. Okay, so minus h over h times square root of 3 minus x plus h plus square root of 3 minus x. Okay, can we simplify this fraction? Why, yes, we can. Okay. And, all right, I'll write the new limit. Negative 1 over square root of 3 minus x plus h plus square root of 3 minus x. Okay, and how do we calculate this limit? It's going to be, well, we can plug in 0 for h, so it's going to be negative 1 over square root of 3 minus x plus square root of 3 minus x. All right, so I've got 2 copies of this, so I can rewrite this as negative 1 over 2 root 3 minus x. That is your derivative. All right, and to find the tangent line at x equals 2, the slope is going to be what happens when we plug in 2 into the derivative. So negative 1 over 2 square root of 3 minus 2, 1 over 2 root 1, negative 1 over 2. That's your slope. We also need a point we need a slope and a point to get the equation of the line. So to get the point, well, the x-coordinate is going to be 2. The y-coordinate for a point on this graph would be f of 2. Okay, and how do we find f of 2? We plug in 2 into here. Okay, so it'd be 2 f of 2. So square root of 3 minus 2. So that's just the square root of 1, which is just 1. Okay, so that's the point. Once we have the slope and the point, we can use this formula. Y minus y1 is equal to m times x minus x1. So y1, that's your y-coordinates. M is your slope, and x1 is your x-coordinates. Okay, let's get y by itself. All right, we'll get rid of the parentheses first. Yeah, this times this would be, 1. Y is equal to negative 1/2 x plus 2. This is your answer. Now for the normal line, the slope is going to be perpendicular to that of the tangent line. So if the slope, because since this line is perpendicular to this line, to find the new slope, it's going to be negative 1 over this. Okay, with division, double negatives make a positive, so these will go away. 1 divided by 1/2 is 2. That's your new slope. And they're going to pass through the same point, so we can reuse this. And then we'll use this formula again to get the equation of the line. Get rid of the parentheses. This is your answer.